this. Alright, so this is the Friday 5th period video where I'll do 9, 12, and 15. So, number 9. The antiderivative from -1 to 2 of that thing. We haven't seen that thing in a while, but we need to know what that thing looks like because the AP test likes to ask questions about that thing. So, do you remember what that looks like? If you don't, I guess you could plug in values and see. So if you plug in, if x is positive, then everything's positive and you just get 1. So there's x being positive. If x is negative, let's see, we would get -1. Alright, does that picture look familiar from long ago? Because we can ask derivatives and limits and areas and all sorts of things. So again, you need to add that to your sort of your memory bank of parent functions, what that looks like. Alright, so if I know what the picture looks like, I'm not going to work this problem as an antiderivative. I'm going to work it as an area problem. So I want the total area from -1 to 2. Although I need to be careful here. What's this area below the axis? It's 1, but negative. The other one's 2. So I guess I should say, I'd be careful. The area is 3, but the integral is 1 because part of that area is negative. Again, if you know the picture, it's not hard, but you got to know the picture. All right, number 12. 12 is tricky. Well, there's a long way and a short way to do number 12. The long way would be evaluate everything and see what's going on. But I'll see if we can come up with a shorter way to do this. The integral from 0 to pi of sine of x. Okay, so again, the long way would be the antiderivative of sine is negative cosine, and we go from 0 to pi and plug it in, and then I got to plug in all of those and see what works. I think a better way would be to think about the area way. Of course, you'd have to know what the graph of sine of x looks like. Like that. So, and it was from 0 to pi, so it would be this area. Okay, that first option, the area from negative pi over 2 to pi over 2 of the cosine of x. Do you remember where cosine starts? When x is 0, what's the cosine of 0?
Isn't it just like flipped over the x-axis?
Flipped what flip? Flip the sign?
Yeah, like everything. Like if it's cosine, you just kind of flip it, or like move it a pi to the right.
Okay, move it, but not flip it.
Okay.
In fact, I'm going to move it pi over 2 because cosine starts at a maximum. And pi away, it's at a minimum, so it looks like this. So part A is asking me to find that area. Well, we got lucky because those are the same areas. So I don't really have to find the area. I just know that those are the same, so I know it's part A, or it's answer A. Again, that's the quick way to do it. The long way would be to do all of those antiderivatives and get what they're equal to, and that would be the only one that works. Let's see. From 0 to pi, that one would be 0 because half of it's above, half of it's below. from 0 to negative pi, that would be negative, that part. And that one would be 0. So yeah, part A is the only one that matches the picture.
Can I come watch?
You can come watch. Yes. But some of your biggest fans aren't here, Miss Craig.
Oh,
The Apes field trip wiped out a bunch of people.
yeah.
So
They should have checked with me first.
they should have. Number 15. This is the last one, and then we'll watch the fun video. It's loosely related to calculus. The graph of the differentiable function is shown. This is like the last example we did, or the last notes page thing we did. H is the area from 0 to x of this thing. Which of the following must be true? And we're comparing h to h prime to h double prime at 6. So, let's see, I need h of 6. Ugh. So the area from 0 to 6 under the curve, what could you say about that? As in, right, it's this area, but I don't know what that is, and I don't have an equation to integrate. Is there any conclusions you could make about that area? What's that? It's negative.
That's my girl.
It's negative. That's all I know, so I I hope that's enough. H prime at 6. Well, that means I need the derivative of this thing. So I need the derivative of the antiderivative. Oh, but that's good news, right? Like, it looks complicated, but it's good news. JT, because what's the derivative of the antiderivative? Remember, this is my favorite Algebra 1 question to ask without giving them a calculator, and it stumps those poor kids because they can't figure out. They just cancel each other out. And so h prime of 6 is the same thing as f of 6. So f of 6, blowing through the popsicle sticks today. Jackson, what's f of 6 then?
0.
That's just 0. Let's see, h double prime of 6. So I want the second derivative of h. Bo, how am I going to find the second derivative of h?
You take the derivative of f6, so f prime 6.
Okay. And what do I know about f prime?
It's 0.
At the f prime?
No, f prime, it's the opposite.
So here's f. I want f prime. What does f prime tell me about the graph of f?
Oh, it's increasing or decreasing.
Okay. So what's happening at 6?
Oh, it's nothing, so stationary.
You had it right the first time. We're
Oh,
we're
okay.
going up. So what does that tell me about f prime at 6?
Oh, it's increasing.
It's careful. It's positive.
Yeah.
It's not necessarily increasing. It's positive. Because the slope, this would have been a better way to say it, the slope of f is positive. Okay, so now I can put these in order because all I'm worried about is negative, 0, and positive. So, and they even put them in order for me. Negative, 0, positive. So negative is less than the derivative is less than the second derivative. Part A. Again, that is definitely an old AP test question because it tests 14 things in one question. All right, we'll stop there. I'll post more videos